Hello, welcome to Plutus IS. Today we are going to discuss about the find the number of elements of particular order in symmetric group. So, number of elements we are going to discuss about the how to find the number of elements of order D in SN. SN means permutation group or symmetric group. So directly we are going to use the formula how to find the number of elements of order D by using the directive formula. And formula is that so number of elements of order D in Sn is equal to the summation of factorial n upon 1 to the power k. Suppose here alpha 1, alpha 2 and alpha k, and here factorial alpha 1, factorial alpha 2 and so on alpha. Okay, so this is the formula. And what is the 1, 2 and k? So here LCM of 1, 2, k equal to d. So now we are going to use this formula to find the number of elements of particular order d in Sn. So we will explain through the example what the mean here, what is the LCM of 1 to k and so on. So such that get the d. For example, suppose we have to find the number of elements of order 6 in Sn S5. So S5, this is the PYQ also. In UPSC many questions have been asked like this: find the number of elements of particular order in given any particular permutation group. For example, here the number of elements of order 6 in S5. So first we have to check that order 6, and we know that when the order will be the 6, if you can write any permutation in the product of disjoint cycles, then order of any cycle of length r is r, and how to find the order of any permutation right in disjoint cycle, then directly find the LCM of those orders of cycles. So here we have to find the 6, that simply write the partition 5. Here S5 group is the S5 symmetric group of degree 5, that means write the partition 5. Write the partition 5 in such a way that LCM of those numbers will equal to the 6. Then as partition of 5 can be written as the 5 equal to 5. Okay, you can also write the 5 equal to like the 4 plus 1. 5 equal to can write the 3 plus 2. 5 equal to can write the 3 plus 1 plus 1. You can write 5 equal to 2 plus 2 plus 1. You can also write the 5 equal to 2 plus 1 plus 1 plus 1. You can also write the 5 equal to 1 plus 1 plus 1 plus 1 plus 1. Okay, so these are the partition of 5, and these are actually the 1, 2, 3 and k. Okay, so now like in this case we have to find only particular order of 6 elements of order 6. So just check which numbers will give the LCM of numbers will be equal to the 6. LCM of only here the 5 to 5, here LCM of 4 and 1 will be the 4. Here LCM of 3 and 2, here you can see the LCM of 3 and 2 equal to 6. So only partition. If you take the LCM of 3, 1, 1 will get the 3. LCM of 2, 2, 1 will get the 2. 2, 1, 1 so on and so on get the 1. So only in this partition we are getting the LCM is 6. So in this case that means actually permutation of S5 is a disjoint cycle of length 3 and length 2. That's why you directly use this formula to find the number of elements in particular order. So I'm just give you the direct idea how to find. So use this formula, number of elements of order D in Sn. Directly you can use this formula where 1 to k and actually the partition, those number which are using in the partition 1, 2 and k, such that LCM equal to D. So in this example, I suppose we have to find the number of elements of order 6 in S5. Then take the partition of only those which are giving LCM is equal to the 6. So only in this case we are getting. So that is actually 1, 2 and 3. So now therefore number of elements, therefore number of elements of order 6 equal to factorial n. And what is the n? N equal to 5 here. Here n equal to 5. So factorial 5 upon, use the partition only which give the LCM 6. Here 3 and 2. So you write the 3 to the power 1 and 2 to the power 1. How many are using? Like they are 3 one time, 2 one time. Suppose in this case 2 are 2 times, to write the 2 to the power 2 and 1 to the power 1. Like in this case 1 to the power 5. Here 2 to the power 1 and 1 3 times, so 1 to the power 3. So here both are 1 time, so simply write the 3 to the power 1. That is the 1, 2, k and so on. And this is the alpha 1, alpha 2. So factorial 1 into factorial 1, you can calculate it, you will get the what? Factorial 5, 4 and 3 and 2 will be cancelled out, means finally what will you get? The 20. So there are 20 elements of order 6 in S5. Suppose you have to find the number of elements of order 2 in S5, then just check the partition where the LCM will get the equal to 2. So we can see that the LCM here will get the 5, here LCM you can get only the 4, here 6, here 3. In this case you will get the LCM is 2, like the LCM of 2 to 1 equal to 2, LCM of 2 1 1 1 equal to 2. Therefore these two partitions we have to use to find the number of elements of order 2. In these two cases we are getting the LCM 2. We are getting the LCM 2. So now if you want to find the number of elements of order 2, then we have to use number of elements of order 2 equal to, now observe the formula. Why using the summation? In first case, in order 6, elements of order 6 only one partition, but in order 2 we are getting the two partition, and that we use the summation. And we have to add both. So here just calculate it. So number of elements of order this will be 2 times. So factorial 5 upon, in first partition 2 is 2 times and 1 is 1 times. So simply 2 is 2 times, so like this, and 1 is 1 times, and now factorial 2 and factorial 1 plus, this is the plus for second partition, as both are giving the LCM 2. Here 2 is 1 time and 1 is 3 times. So 1 is 3 times and 2 is only 1 time, so factorial 3 and factorial 1. Simply you have to calculate it. So whatever you get, the 2 to 4 will be cancelled out, 2 factorial cancel out. That means if you calculate, then 4 cancel, that means 5 and 3 means 15, and plus, okay, 4, yes, here you will get the what? Factorial 3 up to factorial 3 is cancel out, and 5 4 means 20, and divided by 2 means 10, means total will get the, you can calculate just simply calculation, 25. So there are 25 elements of order 2 in S5. Similarly, you can calculate the elements of order 5 by using this partition, elements of order 4 by using this partition, elements of order 3 by using this partition, as LCM will be here 3, elements of order 1 by using this partition. And suppose the question asked, find the number of, is there any element of order 8 in S5, then you can check none of the partition will give the LCM is equal to 8. That means there is no element of order 8 in S5. So by using this formula, in general, suppose you have to calculate the number of elements of particular order in S4, n will be the 4, and any d can be any order, like the order 6, order 5, or whatever. Just check if partition is possible or not to give the LCM is equal to that particular d. If possible, then you can calculate the number of elements of that particular order d in Sn by using directly this formula. So we will see more examples about the order of elements in Sn and also the alternating group of An in upcoming videos. Thank you.